So here we are, another beautiful day and another great day to be talking some math. So today we're going to talk a little bit about solving linear equations and some of the implications in solving algebraically. How does that relate to solving graphically, solving numerically with a table? All those good things are going to be covered in this mini lecture. So we're going to start with just the idea of how do you solve a linear equation. And so we're going to start with something that kind of looks like this, where we have, notice that there's one variable, x, and it's not raised to any power, it's just x, so it's a linear equation if there's no power greater than 1. And when we see something like this, what we want to do first is eliminate any parentheses by distributing what's in front of it to each term within the parentheses, and then we'll collect like terms. So the very first thing we're going to do, we're going to take a look here, and we're going to take this -2 and multiply it through, and we're going to take what's in front of this parenthesis, which is 1, right, and multiply it through. So take a second, jot down this equation, and take that moment to distribute the -2 and the 1 through the parentheses and eliminate those, and then we'll move on from there. Okay, so when we have distributed those two things, we should end up with an equation that looks like this. Really long equation, but so many things that can be combined. So we want to take and bring all of our x terms to one side and all of our constant terms to another side, but that may seem like a daunting task initially when you have a really large equation like this. So for many students, it's very helpful to take your left-hand side and simplify it to just an x term and a constant term, and take your right-hand side and do that as well. So let's do that. We have 5x minus 2x on the left-hand side gives us 3x. And then we have 2 minus 2 minus 6, which gives us minus 6. On the right-hand side, we've got x plus 3x, which is 4x. And we have -5 minus 4, which is minus 9. So we end up like this. Okay, so now this is pretty easy. We want to take our x terms and combine them into one term on one side of the equation, and our constant needs to go on the other. Okay, so it does not matter. We can take this 4x and bring it over here, or we can take this 3x and bring it over here, either way by subtraction. And then wherever we bring the x term to, the constant needs to go to the other side. I personally will choose the side of the equation that has the greater number of x's. That's going to make our x term positive. Okay, so let's take, we're going to keep the 4x here, and we're going to bring the 3x over here by subtraction, which means we're going to take this -9 and bring it over here by addition, and let's see what happens there. Okay, all said and done, and we get x is equal to 3. Now the great thing about solving algebraically is you take that x equals 3 and you substitute it back in, and you should get a true statement. When you put the 3 in for every x value, let's see, here, 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 and here, we should get a true statement. Okay, so when we substitute all those 3's in, we end up with something like this, which we end up with 2 plus 15 minus 8 minus 6, or 17 minus 14, which is 3, is equal to 3 plus 3 times 3, 9 minus 5 is 4. 3 plus 4 minus 4 is also 3. So we do end up with that true statement, which lets us know that we are absolutely correct with our solution. What if we have something like this, where we have an equation that has fractions in it? Everybody loves fractions? Raise your hand. Oh, I don't see anything. Okay, so you're probably one of many that do not like fractions at all. And if that's the case, then there's a very simple solution. We ask our fractions to leave. If you ask them politely, they go away. And the way we ask them politely is we determine what the least common denominator is here, and we multiply everything through by that least common denominator. So we have a denominator of 3 and a denominator of 7. So the least common denominator, or LCD, is 21. Okay. So then we're going to take that 21 and we're going to multiply it by each bit here. Okay. So if you multiply 21 by each piece, this is kind of what it looks like. And then you may be able to see that if you're multiplying these things together, I'm multiplying 21 times this thing, dividing by 3. I can really just take that 21 divided by 3 and multiply by this thing. So 21 divided by 3, that's the same as 7. So this would be 7 times x plus 1 equals 21 times 5 minus, now I've got 21 divided by 7, or 3 times x plus 2. Yippee. Now we are sitting looking at something that looks a lot like our former example. No fractions, and we just have parentheses, so we're going to distribute, collect like terms, and go ahead and solve the equation. So you go ahead and distribute, we'll collect like terms together, and then we'll solve. So we end up with 7x plus 7 equals 105 minus 3x minus 6. So let's take our negative 3x, bring it over here. We're going to add it, and we'll end up with a 10x over here. Then we're going to take this 7 and bring it to this side. So we're going to subtract 7, and we've got a positive 105 and a negative 6. We get, 10x is equal to negative 92. We would finish this by just dividing both sides of the equation by 10, and x would equal negative 9.2. Or negative 9 and 2/10, or negative 9 and 1/5, or another way we could say that would be negative 46/5. Okay, so all of those would be correct answers. Okay, so the next part of this we're going to look at is solving a linear equation with a graphing calculator. So that brings into discussion, how does a graph relate to solving a linear equation, and also how can we look at a table of values and decide what the solution is. So let's take a look at this equation. Negative 1/2 x minus 3 is equal to 6 times x plus 1 minus 2x. And of course we can do what we've done before and solve this algebraically, but we're going to use this as an example to solve both graphically and with a table. So what you're going to do is you're going to get your handy dandy little graphing calculator out, power it up, right, turn it on. Okay, and what you're going to do is, I'm going to bring it in to show you, you're going to go to y equals and put the left hand side of the equation into y1. You see how we have that there? And the right hand side of the equation into y2. Okay, so put one side of the equation into one of those two things and the other side into the other. And it doesn't matter, you can put that 6 times x plus 1 minus 2x into y1, and that negative 1/2 x minus 3 into y2. It doesn't matter, just one side in y1, the other side in y2. Then what you're going to do is you're going to hit graph. Okay, and you get this nice little graph. One of these lines represents one of the equations and the other line represents the other. What we are looking for, what are we solving for? We're solving for x. We're looking for the point of intersection, okay? What is a coordinate of that point of intersection? And our solution to our equation is that x value. So you can kind of look and guess, but your answer is not really precise. Fortunate for us, if you use the tools of the calculator, it'll tell you. So go to Second Calc, and your options will be all these nifty little things. And what are we looking for? We're looking for the point of intersection. So we're going to either scroll down or just hit 5 for intersect. And now it's going to ask you, which two lines or curves are you interested in the point of intersection? Well, that's because you could put several things in those y1, y2, y3, y4, right? And we are interested in just the first two. Well, if you only have two, you can just default enter, enter for first curve, second curve. It'll just default to the 2 that are in there. And then it's going to say guess, because in some cases, if it's not lines, you may have more than one point of intersection. In this case, there's only one. So let's just cursor so we're close to where that point of intersection is, okay? And we're going to press enter. And then you'll see at the bottom of your screen, it'll tell you the intersection. The intersection is -2, -2. And what we're interested in, it doesn't matter in this case because you've got an x and y that are the same, but we're interested in the x value. The x is -2. That means our solution is -2. Okay. So how does that relate to a table of values? Well, if you're given a table of values, and you can just hit your table button, second here, graph here gives you the table of values, and you are examining this table of values, you can find your solution by just scrolling down until you find a y1 and y2 that are exactly the same. Here we have y1 and y2 that are different. Next one, they're different. The next one, they are different. But when we get to this 4th entry, they are the same. Okay, yay, they're the same. What's our answer? The answer is the x value there. Okay, so that's how you use a table and a graph to solve graphing or solve linear equations. The great thing about it is those techniques can be used for just about any kind of equation. So if you know how to use your technology, it can help you. Depending upon how your instructor allows that kind of technology, it may be a great way for you to either verify your answers or just complete the problem. Okay, so the next thing we're going to talk about are 3 different types of equations, and this is not just restricted to linear equations. There are really 3 different kinds of equations, and we're going to talk about these 3. Conditional equations, identities, and inconsistent equations. Really what this boils down to is this. Equations can be always true, equations can be sometimes true, or equations can be never true. Equations that are always true, doesn't matter what is substituted in for the variable, are called identities. So let's write that down. Equations that are always true. And these equations often, if they're simplified, look exactly the same on one side as the other. For example, 2x minus 7 equals 2x minus 7. An identity. It does not matter what I put in for x, that equation will be true. Okay, so what about equations that are sometimes true? Sometimes we have, and this is the case often in algebra, you have an equation that you can solve for the variable. The variable is x is equal to 2. That's really saying that this equation is true on the condition that x is 2. Okay, so it's a conditional equation. So these are equations that are true on a given condition. Equations that are true under a given condition, such as x is equal to 2. And an example of that would be like 2x minus 7 is equal to -3. Okay. 2x minus 7 is equal to -3, and this would be true if x was equal to 2. Anything that you can solve for x for is conditional, all right? And you can recognize this if you're looking at a linear equation. You'll have a different number of x's on one side of the equation than the other, okay? And that will tell you that you have a conditional equation. The last kind of equation that we are looking at are inconsistent equations. These are equations that are never true. There's nothing I can substitute in for my variable that will make it true. Okay, so these are equations that are never true. And an example of that might be 2x minus 9 is equal to 2x plus 1. Okay, so you tell me this. What value can I double and subtract 9 from, which will be the same as doubling it and adding 1 to. You can't do it. There's just nothing that you can double and subtract something from and add something from it. It'll end up being the same. Inconsistent equations are never true. One way you can recognize these, if it's in a linear form, is you'll have the same number of x's on both sides, but the constant value is different. So if that's the case, you have an inconsistent equation. All right, so let's look at some examples and identify what's going on with those examples. All right, so here are 4 examples. 15x plus 5 is equal to 5 times 3x plus 1. Is that always true, sometimes true, never true? Well, if I actually distribute that 5 through, what happens to that right-hand side? Well, that becomes 15x plus 5. Is 15x plus 5 equal to 15x plus 5? Absolutely, all the time. Doesn't matter what x is, so this would be considered, yes, you are right, it's an identity. Okay, next example, we have 3x plus 9 is equal to 3 times x minus 3, also known as 3x minus 9. 3x plus 9, 3x minus 9. Oh, when is that true? Okay. When can I triple something and add 9 or subtract 9 and it's the same thing? That never happens. Again, 3 x's on both sides, same number of x's, but the constant value is different. So this is inconsistent. Okay, inconsistent. All right, so this one, 8x plus 10 is equal to 12. Notice, remember, I said that if you have a different number of x's on the left side than the right side, it's going to be a conditional equation. You can actually solve for x. And so we can call this conditional. And let's go ahead and solve for x, because that gives us what is the condition. So 8x plus 10 equals 12. Subtract the 10 on both sides, and we get 8x is equal to 2, or x is equal to 1/4. Okay, and the last one, let's see, 8x plus 4 is equal to 5 times x plus 2. Okay, otherwise known as 8x plus 4 is equal to 5x plus 10. Different number of x's on both sides. I've got 8 of them on the left and 5 of them on the right, which means that I can solve for x and find the condition that this equation is true for. So let's go ahead and subtract the 5x and subtract the 4. We'd end up with 3x is equal to 6, x is equal to 2. Okay, so this is saying that this statement or this equation is true on the condition that x is equal to 2. So, of course, when we plug in that 2, I get 16 plus 4, or 20 on the left-hand side. 5 times 2 is 10 plus 10, 20 on the right-hand side, and that's the only thing that's going to work out for us. All right, I'll see you in class tomorrow.